Let's continue now and take a look at another component that's often vital to measurement and diagnostic analysis, the injector. Now, we're also going to bring into use the high-frequency sensitive current inductive clamp, and this is it. In effect, what this does, it measures current but displays it as a trace or a waveform, and there's an incredible amount of evidence that's diagnostic. It's absolutely critical for good diagnostic evaluation. So let's go through the same procedure. We're going to connect to the vehicle first of all. Now, obviously you'd use a wired diagram or schematics or a plug profile map to connect to the various components, but I've used an acupuncture probe, the back of the injector, so I've gone down parallel alongside the cable onto the back of the pin, and I'm going to use channel A as the triggering channel. This will pick up a pulse or a waveform profile of the injector. And I'm also going to use the sky hook again, just to keep the leads away from heat and electrical noise, particularly ignition, and I've left the ground reference on the battery. And we need to switch the inductive current clamp on. 20 amp range is the appropriate one, and we may have to zero the tool later on, which I'll come back to that in a moment. This is directional. Now it's lucky go. If you've no trace, then it's upside down, so we'll see how we go. Engage the shortcut and launch Pico. I'm going to begin from scratch again with the pop-up menu from automotive and select automotive, actuators. Actuators are devices that use a coil, therefore current, so there'll be a whole range of components within that section. And down to injector and petrol. You'll also notice that diesel injectors are provided for with common rail. And now we have a whole host of choices. I want to measure injector voltage and current, which is next to the last option, so I'm going to tab down to that and engage. And once again we're into the help menu, and here I'll just pop through this. A whole range of advice based on what an injector is, how to connect. It's discussing the use of the inductive current clamp, and for me that's one of the most vital tools. You'll really get to love that tool when you use it. And there we have the sample waveform. I'm going to discuss the two images that we pick up in real time in a moment. Notes on the waveform, some technical information, and of course we can then simply minimise, and then we can always go back and refer to that data if we need to. There's a sample waveform that's simply frozen on the page, ready to push the space bar, and then we're live and running. David, if you can fire up please. Attenuator is still in, of course, and we need to use the attenuator because this is an inductor or coil. And let's run live. Right, you can see now that the image is running live. Let's take the triggering channel, the actual pulse, which is channel A in blue. The actual fuel delivery period is clearly displayed between the grounding of the power signal to the point where the injector is switched off and get this back EMF, which is one of the critical diagnostic measurements we can observe. And it's because of that that we use the attenuator, so the whole thing fits on the screen. For me, current tells far more about what's actually taking place. And you may notice this little event here, this knee-jerk reaction within the current ramp. That's the instant that the pintle actually snaps back against the spring. So in effect, that's the point where the injector pintle actually does leave its seat and open fully. So you could argue that's the point of commencement of fuel delivery. And you'll also notice it's current control. So the PCM is actually controlling the maximum amount of current delivered to that injector. And this little trace here on the pulse, on the waveform pulse, is the point when the injector actually closes, physically closes mechanically. So for obvious reasons, the mechanical operation of the injector is delayed slightly from the actual electronic switch on and close. From that we can measure current flow, determining whether the PCM is actually switching sufficient current through the injector, if the injector itself has a good coil, in other words, is the current too great, is there a short? Poor current would probably suggest poor power supply or poor ground reference through the PCM. So from this we can really discuss any combination of faults that we may find with this particular component. And of course, if you need any assistance, we've got the whole help screen minimised on the bottom spacebar, so everything you need once again is to hand, and the setup couldn't be simpler. All I've used are preset menus and basically I've actually done what I've been told from the screen setup.